Hello everyone. Today let's solve the problem number 875. Koko eating bananas. So just go through the problem and try to understand the problem with the help of example. So I'll just summarize the problem for you so that it will be easy for us to understand and solve the problem, right? So what the question states here, Coco loves eating bananas, right? Coco loves eating bananas and there are n piles of bananas. So they have given there are n piles of bananas. Coco can decide how many bananas she eats per hour. While they are speaking of how many bananas she eats per hour, they have given that it will be in the speed of k, right? So what is the condition here? If the pile has fewer bananas than k, then she eats the whole pile in that hour itself. That is one condition. She must finish all the bananas within h hours. So that's what they have given here. Then again I'll tell. So Coco loves eating bananas and there are n piles of bananas. So you can clearly see here there are n piles of bananas right here. There are n piles of bananas. Coco can decide how many bananas she eats per hour with the speed k. Hours they have given here 8 and we have to basically find the minimum eating speed k. Here minimum eating speed k is nothing but 4 here, such that she finishes all the bananas in this one h hours. She has to finish eating all the bananas within the 8 hours. Here the output we have got here is 4, right? So let's see, let's discuss this example 1. So let's discuss this example. So here what we have to find? We have to find the minimum eating speed k, right? So we have to find the minimum eating speed k uh, that allows Coco to eat all the bananas in 8 hours. They have given 8 hours here, you can clearly see, right? That allows Coco to eat all the bananas in 8 hours for the piles. This one 3, 6, 7, 11 they have clearly mentioned here. So what does eating speed mean here? Mainly if Coco eats at a speed k, suppose k can be anything, right? Eating speed. So let me just delete this one. So if Coco eats at a speed k, it means she can eat up to k bananas per hour. And for any pile smaller than k, she finishes it in 1 hour. This one is important. For any pile smaller than k, she finishes it in 1 hour. For the larger piles, she takes seal of pile by k hours. This one will be seal of pile by k hours. So, for the larger piles, she takes seal of pile by k hours. I'll just give you HRS hours. So, key question here is how do we pick the minimum k here then? So, we have to test the various speeds starting from 1 to 11. You can clearly see here the highest number here is 11. So, we test the various speed from 1 up to the large pile size. Large pile size we have 11 within the array they have given, right? So, by making use of the binary search, we can check if the speed k allows her to finish eating within the 8 hours or not. So how can we verify if the k works? We can do one thing. For given k, we have to calculate the total hours that is needed to eat all the piles. That is one thing. If total hours is less than or equal to hours, here in this case it is 8. We can clearly see. If the total hours is less than or equal to 8 in this case, then k obviously works, right? So result here at k equals 4, pile this one takes 3 takes 1 hour and 6 takes 2 hours and pile 7 takes here 2 hours and pile 11 takes here 3 hours. If we sum this one 3, 4, 5, 6, 7, 8. 8 less than or equal to 8 we have to consider, right? So since 8 hours fits within the given time, k equals 4 is the minimum speed here. 4 will be the minimum speed. So let's do one thing. let's go with the approach. Then let's discuss all the edge cases and write the code and dry run the code for this problem. So you'll understand this one clearly. So let's discuss the approach step by step. So let me give here approach. So here the first step here will be, we are going with the approach binary search to solve this problem. So let's discuss this one step by step. So the lower bound of k is always 1, the minimum speed we are considering, right? So the lower bound of k is always 1, that is minimum speed. The upper bound is the upper bound is maximum pile size, nothing but we can consider directly consider like this, right? For the upper bound we can just make use of the math.max. Yeah, this will be, let's make use of the spread operator of piles. So piles of the bananas. So the upper bound is maximum pile size, nothing but math.max of piles of the bananas, as this is the slowest feasible speed, right, to finish a pile in 1 hour. So this is first step. So and second step, let's move on with the second step. So for each k, nothing but midpoint in the binary search, we have to calculate the total hours needed to finish the bananas. For each k here, we have to this is for each k. While I say for each k, this is nothing but midpoint in binary search. For each k, nothing but midpoint in the binary search, we have to calculate the total hours that is needed to finish the bananas. Calculate total hours needed to finish bananas, right? This is fair, this is fine. The next step is, we have to adjust the search range. So while I say we have to adjust the third search range, let me do one thing here. We go to the next one. So third step, right? So when I say we have to adjust the search range, I'm speaking of if they have given in the question, right? If hours less than or equal to h, then we have to reduce k by searching the left half. So we have to reduce k by searching first half. Searching the left half. We're making use of the binary search, right? So what if hours is greater than or equal to h? If it is greater than if hours is greater than h, then what we will do, we have to increase k by searching the right half. Here we are reducing. Here if hours is greater than h, then we will increase k by same thing, searching the right half instead of left half. So this is the approach that we are going with. So basically this ensures we are finding the smallest possible k satisfying the constraints, right? So I hope this is clear. So again I'll tell what we are doing. So we are going with the binary search for this to solve the problem basically. So first what we are doing, the lower bound of k is always 1, nothing but the minimum speed. So here you can clearly see, and this one is the upper bound is the maximum pile size, nothing but we can just directly make use of math.max of spread operator piles, nothing but while I say piles, it's the piles of bananas, right? As this is the slowest feasible speed to finish the pile in 1 hour. Third step is for each k, nothing but the midpoint, this one. Where did I write this one? Yeah, for each k, that is nothing but the midpoint in the binary search. What we have to do, we have to calculate the total hours needed to finish the bananas. Finally, we have to adjust the search range. While I say adjust the search range, if hours is less than or equal to h, then we are reducing the k to search for the left half. If the hours is greater than h, then we are increasing the k just to search only the right half. I hope this one, the approach is completely clear. Let's do one thing. Let's dry run the first example so that we will understand this one clear. Then let's discuss the edge case and finally write the code and discuss the complexity of the code that we have written. So let's consider the example they have mentioned. So the first example they have given here is just give me a second here. This one, first example, let's consider piles of bananas they have given here 3, 6, 7 and 11, and hours h they have given here is 8. So let's go step by step. We let's set up the binary search. Initially, range of speeds, let's consider range of speeds here. Range of speed is nothing but k here. So left will be 1. We are going with the 2 pointers, left and right? For left will be 1, we have already considered this one, and right will be 11 here. So this is the min speed and this is the max speed. So 11 is the largest, this one, right? Largest pile, the last one. So this will be the maximum pile size, 11 pile size, you can clearly see. So, and initial k, nothing but speed to check here is, we have the formula mid, right? Nothing but left plus right by 2. Nothing but here, according to the example, 1 will start the binary search from 1. 1 to 11, right? So, this will be 1 plus 11 by 2 here, nothing plus and nothing but 12 by 2 is nothing but we get 6 answer here. So, step 2, so let's check for the hours for k equals 6. When k equals 6. So here we have 3, 6, 7 and 11, right? So first one, 3 by 6 will be here 1 hour, 6 by 6 1 hour. So we are making use of the math.ceil, right? So here 7 by 6, again I'll just consider here 7 by 6, this will be 1.17. As we are making use of the ceil, it will be math.ceil, it will get the solution 2. The final one is 11 by 6. Here here it will be 1.83 something. Here also the output will be 2. So the total hours will be 1 plus 1. Here let me do one thing. Let me write this one above. 1 plus 1 plus 2 plus 2. Nothing but here 2 plus 2, 4, 5, 6. Total hours will be 6 in this case. So we know that 6 is less than or equal to 8. H they have given 8, right? So we reduce the right to 5. We reduce the right to 5 here in this step and set the min speed to 6 here. Min speed will be 6 here, right? So this is first step. So we have to check for the check hours for when k equals 3, right? When k equals 3, we have to check. So again, we will perform the same. So now mid will be different, right? So here mid will be 1 plus 5 by 2. Nothing but 6 by 2. We will get the answer 3. So while we consider the each pile, it will be 3, 6, 7 and 11 we have considered, right? K is 3 now. 3 by 3 is nothing but 1 hour. This one is 1 hour. Again 6 by 3, 2 hours. And this one will be 7 by 3. This one will be 2.33 something. Nothing but 3 hours. We will be making use of math.ceil, right? So and finally 11 by 3, nothing but 3.6 something will get. So it will be 4 hours. So total hours here will be 1 plus 2 plus 3 plus 4. Nothing but 7, 9, 10 here, right? So we get the output 10 here. So 10 is not lesser than 8. 10 is greater than 8. So we increase left to 4. We are increasing the left to 4 here and this step. So let's move on with the next step. Nothing but we have to check the hours when k equals 4. So here now we calculate the mid. It will be 4 plus 5 by 2. Nothing but 9 by 2. It will be 4, right? This will be, answer will be 4. And for each pile, it will be 3 by 4. Again, 6 by 4, 7 by 4, and finally 11 by 4. We have 3, 6, 11 and 7 and 11, right? This will be 1 hour again. This will be 2 hours. This will be 2 hours again. This will be 3 hours. So this will we get 1.5 something. We are making use of the math.cell. So we'll consider 2. Same goes with this one, 7/4 and 11/4 as well. 2 hours and 3 hours. So finally, this we can write in this way. 1 plus 2 plus 2 plus 3. Nothing but 3 plus 4, 7. And final answer will be 8 here. So 8 is less than or equal to 8. We know this one. 8 is less than or equal to 8. So we reduce right to 3 and we'll set the min speed to 4. Now we have set the rate to 3 and we are setting the min speed to 4. So finally here the binary search ends basically. So now when we do left greater than right, here left is 4, we know. This one right is 3 here. The minimum speed will be min speed, we clearly know here min speed 4 from the previous one, right? So we'll be considering here min speed will be 4 here. So this is the output that we need to get, 4, and we have got the output 4. So this works absolutely correct, right? So let's see all the edge cases and then write the code, and I'll explain the code while writing the code itself. So now we know the speed with what the Koko eats the bananas within the hours they have mentioned. So let's see all the edge cases and then write the code. So let me come here. Let me give here edge cases. So first one is I'll not be explaining every edge case, each edge case. I have already explained by taking the example one they have mentioned in the question, right? So this is for the single pile of bananas. So input, I'll just consider here piles. This is for single pile of bananas, right? I'll just consider here 100 and here let's consider 1 here. So the output will be 100 here, right? Why the output here is 100? Koko must eat the entire pile in 1 hour. Koko must eat the entire pile in 1 hour. This is for the condition single pile of bananas. Right? So this is for the first edge case. Then let's move on with the second edge case. Nothing but each pile contains exactly 1 banana. So while each pile consists exactly 1 banana, right? So the piles I'll just consider here piles of bananas 1 1 1 here. This is fine. And hearts, let me consider here 3. So the output will be here 1. Why the output here will be 1? Eating speed is 1 banana per hour here. Eating speed will be 1 banana per hour here. 1 banana here. 1 banana per hour. Right? This is fine. This is for the condition each pile contains exactly 1 banana. So I'll just write here each pile contains exactly 1 banana. This is fine. Let's move on with the third edge case. I'll just come here. Let me give you a third one. This is large piles with tight hours. While I say large piles with tight hours, let me consider the example here. 30, 11, 23, 420, anything you can consider. So I'll just consider, in this case, I'll just consider this one. Hours, let me give here 5 and the output will be here 30. Why the output will be 30 here? Koko needs a high speed to finish this one very quickly. So the output will be 30 here. So this is for the edge case large piles with tight hours. And let's move on with the last edge case. Nothing but multiple piles but plenty of time. So piles of banana, let me consider here 3, 6, 7, 11. And hours, let me consider here 20. Here output will be 1. Why the output here will be 1? Since there is enough time, speed can be minimal here. We have enough time here. As they have given 20 here, we have only the highest is 11 piles of bananas, 3, 6, 7, 11, right? So here we have enough time, so speed can be minimal here. We can consider 1, right? So these are the 4 edge cases that we need to consider. This one is multiple piles of bananas, but plenty of time here. This is fine. So what are all the edge cases that we considered here? This one, single pile of bananas, and second one was for each pile containing exactly 1 banana, and third one is large piles with tight hairs, and the fourth one is multiple piles but we have plenty of time. So these are the 4 edge cases that we have considered. So next, let's start writing the code, and I'll explain the code while writing the code itself. And finally, let's discuss the complexity of the code that we have written. So initially, as we had discussed in the approach, let's initialize the binary search range. I'll just give here left equals 1 and right. We have already considered, we have already seen this one, math.max of piles, right? Piles of the bananas. So they have given here piles, right? Piles of the bananas. And also let's consider min speed here. Min speed, let's initialize this one to the right pointer. This is fine. This is the first step. Then we have to perform the binary search now. So whilst left less than or equal to right, this has to be true, right? At any cost. So while left is less than or equal to right, then we have to calculate the midpoint speed first. Nothing but I'll just give here, let mid. Instead of mat.floor, I'll just give in this way, left plus right minus left 1. So this performs the same operation as left plus right by 2. Usually we make use of the double tilde operator or the mat.floor of left plus right by 2, right? It performs the same operator. Instead, we are considering here this one. We are making use of the right shift operator, right? This it performs the same operation as this one, left plus right by 2. The next step here is, after calculating the midpoint speed, we have to calculate the total hours that is required at the current speed. Initially, let's initialize the total hours here to 0, and let's make use of the for loop. So I'll just give here, let's consider individual piles of the bananas. So we will be making use of the seal. We have already seen that one in the example. We'll be making use of the seal to account for the partial piles, right? So I'll just give here total hours has to be total hours plus math.seal of pile by mid. We have already seen this one in the example. I hope this is clear. So the next step would be, let's check if the total hours is within the limit or not. We have already discussed this one, right? So this is simple. If this is pure binary search, this one, let's consider total hours less than or equal to h hours, then we will update the minimum speed. So min speed, we have already considered this one. Let me copy paste this one itself. So sorry, what did I do? Yeah, min speed, let's update the min speed. Then we have to search in the right half for a smaller speed, and we have to search in the right half for the largest, this one, larger speed. So what we are doing here, first we have to check if the total hours is within the limit or not. If it is, then we update the minimum speed. Then we will search in the left half for a smaller speed, or we have to search in the right half for a larger speed. I'll just write in this way, right equals mid minus 1. This is, we are searching in the left half, right, for the smaller speed. This is fine. Else what we will do? we have to search at the right of for a larger speed. Nothing but left equals mid plus 1 here. I hope this is clear. Oh, sorry. Why this one? Yeah. Finally, we have to return the minimum speed that is found. So here I'll just give min speed. So let me format the code once. So let's hit the run button. So I hope the code works. Yeah. You can clearly see the sample test cases are getting passed. So let me hit the submit button. So you can clearly see all the test cases are getting passed. So the code works absolutely correct. So let's quickly discuss the time and space complexities, right? So here the overall time complexity would be big O of n into logarithmic max of piles of the bananas. So here, did I miss something here? Yeah, nothing, right? Yeah, this is fine. So this is big O of n into logarithmic max of piles. What is this n here basically? Here n is for calculating the total hours for each speed. We know this one, right? And log of max of piles, whatever I have given here, this one, this is nothing but this is for the binary search, right? Log of n, we know. So overall time complexity would be big O of n into log of max of piles. So what will be the space complexity here? Overall space complexity would be big O of 1 because we are not making use of any extra space except for some variables that we have used here, left, right, min speed, anything it might be. So overall space complexity here would be big O of 1. So yeah, I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.